Good morning, students. In today's lecture, we will discuss shortest job scheduling algorithm, preemptive version. Now, let's take an example of that. Here, a table is given in which there are 4 processes, and the arrival time of each process and the burst time of each process is given here. So, as you can notice here, that P1 arrives at time 0, and the burst time of it is 8 millisecond or any unit. The process P2 arrives at first unit of time and the burst time is 4 units and so on. So here we are using the concept of preemption. So to make the Gantt chart, see, this is the Gantt chart of this. Now have a closer look of this. First of all, at 0th unit of time, process P1 arrives and the burst time of it is 8 units. So the CPU is allotted to process P1. When the process P1 is executed, after 1 unit of time, process P2 arrives. Means process P2 arrives at 1 unit of time. So the remaining burst time of P1 is 7. As it has been executed for 1 unit of time, the total burst time is 8 unit of time, and it has been executed for 1 unit of time, so the remaining time is 7. Okay, process P2 arrives at first unit of time and the burst time of process P2 is 4. So in shortest job first, what we do is we allocate the CPU to the shortest job. So as compared to the P1, P2 is the shortest job, right? So CPU is allotted to the P2. The burst time of P2 is 4 units of time. So the P2 executes for further 4 units of time, means from first unit of time to 5 units of time. Okay. Now, while the P2 is executing, at 2 unit of time, P3 comes. But the burst time of P3 is 9. And the burst time of P2 is what? P2 is executed for 1 unit of time. So the remaining burst time is 3 units of time. So burst time of P2 is 3 and burst time of P3 is 9. So the preference will be given to the process P2. So the process P2 is not preempted. As in the case of P1, the P1 had higher burst time as compared to the P2. So P1 was preempted. But in the case of P3, P3 is having higher burst time as compared to the P2. Right? So CPU is allotted to the P2 only. Right? So P2 is not preempted. Now burst time of P2 is 4. So P2 executes till 5 units of time. Now after 3 units of time, P4 also arrives, and this P2 completes its execution by 5 units of time. Means at P3, when it comes, P4 comes, the burst time of P4 is 5. But the remaining burst time of P2 is what? At 3 units of time, the remaining burst time will be 2 only. So P2 will be given the preference over P4. So P2 completes its execution, right? Now after this, check the lowest burst time. It has executed for 1 unit of time. P2 has completed its execution. P3 needs to be executed now, and P4 is 5. So next is the remaining burst time is 7, this is 9, and this 5. P2 has completed its execution, right? So we have 7, 9 and 5. So finally the CPU is allotted to P4, right? And the burst time of P4 is what? This 5 units of time. Now as you can see here, other processes P1 and P3 are having larger burst time as compared to this P4. So P4 is given preference. So P4 completes its execution. So CPU is allotted to P4 for further 5 units of time, and P4 completes its execution. Now we have P1 and P3. So P1 is having lesser burst time as compared to the P3. So the CPU is allotted to P1, and the burst time of P1 is 7. So P1 executes from 10th unit of time to 17th unit of time, and finally P3 is executed. Okay, I think the Gantt chart is clear to everyone. Next we have to calculate the waiting time, and the formula for calculating waiting time in the case of preemption is the waiting time is equal to total waiting time minus number of milliseconds process executed minus arrival time. Okay, so we will put the values of these processes in this formula. So waiting time for P1 is, see, total waiting time. P1, see, P1 completes its execution here 17, and P1, the total waiting time is 10. P1 executes here but only for 1 unit of time, and till 10th units of time P1 is waiting. Okay, so the total waiting time is 10 units of time, but P1 has executed for 1 unit of time, so minus number of milliseconds process executed. So P1 has executed for 1 millisecond, so we put here minus 1, and minus arrival time. So P1 arrives at time 0. Okay, so after putting all these values, we get 10 minus 1 minus 0 is equal to 9 milliseconds. So the waiting time for P1 is 9 milliseconds. Next, waiting time for P2 is, total waiting time is 1. Look at this. Here we have P2, and P2 is only here. Okay, P2 waits for 1 millisecond minus number of milliseconds process executed, which is 0, minus arrival time. What is arrival time? P2 arrives at 1 millisecond. So the waiting time for P2 will be 1 minus 0 minus 1 is 0 millisecond. Similarly, for P3, total waiting time is 70. See, look at this. For P3, the total waiting time is 70 minus number of millisecond process executed. P3 is not executed before, so execution starts from here only after 17. So this term will become 0, and the arrival time of P3 is what? 2. right? So the waiting time for P3 is 17 minus 0 minus 2, which is 15 milliseconds. And similarly, we can calculate the waiting time for P4, which is 5 minus 0 minus 3 is equal to 2 milliseconds. Now calculate the average waiting time using the same formula, summing up all these terms divided by total number of processes, that is 4. So the average waiting time is 6.5 milliseconds. Okay. Sometimes the preemptive shortest job for scheduling algorithm is called shortest remainder time for scheduling algorithm. Okay. So in the next lecture, we will discuss a solved example based on shortest job for scheduling algorithm. So thank you so much. Have a nice day. Thank you.